Good day everyone, I am John Bernard Lumantas. I will be your teacher on this subject for the entire semester. Our topic for today is about operations on functions. As you may recall, there are four basic operations in mathematics: right, plus, minus, times, divide. In this lesson, specifically, we can apply what we have learned in our main topic recently, which is all about functions. They are sum of two functions, difference of two functions, product of two functions, quotient of two functions, and lastly is the product of a constant and a function, which is basically interrelated to multiplications. Our objectives for this topic is that students are expected to enumerate the steps on how to perform the different operations on functions, perform addition, subtraction, multiplication, and division of the function. Two functions. Firstly, when we say sum is the result from the addition of two or more numbers. But in this case, we deal with functions. So sum of two function is about adding two or more function. It is defined by the equation f of x plus x of g equals to f plus g and x. To gain more understanding on what sum of the two function is all about, we are to answer an example for this subtopic. First, we define two functions of f and g. F of x, 3x squared plus 8x minus 4 equation to 2. And g of x is x cubed minus 14x squared minus 6x plus square root of 2. Solution: f of x plus g of x may equal to f plus g is x. 3x squared plus 8x minus f square root of 2 plus x cubed minus 14x squared minus x 6x plus square root of 2. 3x squared plus 8x minus 4 square root of 2 plus x cubed minus 14x squared minus 6x plus square root of 2. We will arrange the polynomials in decreasing order according to its degree. X cubed plus 3x squared minus 14x cubed squared plus 8x minus 6x minus 14 square root of 2 plus square root of 2. The answer is f plus g is x equal to x cubed minus 11x squared plus 2x minus 3 over 2. Two functions. Secondly, the next operation we need to discuss is subtraction, or shall I say the difference of two functions in order to gain an insight. I'll demonstrate to you an example. By the way, The two functions of f and g we will use is from the previous example. So the expression is f of x minus g of x. F of x minus g of x equals to f minus g equals to x. 3x squared plus 8x minus 4 square root of 2 minus x cubed minus 14x squared plus 6x plus square root of 2. We will distribute the minus sign for the second function. The trick is you will just reverse the sign from the positive to minus. Minus to positive, 3x squared plus 8x minus 4 square root of 2 minus x cubed plus 14x squared plus 6x minus square root of 2 minus x cubed plus 3x squared plus 14x squared plus 8x plus 6x minus 4 square root of 2 minus square root of 2. Negative x cubed plus 17x squared plus 14x minus 5 square root of 2. After subtracting, we will move on towards multiplication, or shall I say the product of two functions. Here we will multiply one function to another. I hope you remember the rule of exponent here because it is very important. X times x is equal to x squared. This rule states that when multiplying two bases of the same value, keep the bases the same and then add the exponent together to get the solution. I'll demonstrate to you in one example. We first define two functions f and g. f of x equal to 2x squared plus 3, g of x equal to 4x minus 1, f of x times g of x equals f times g x equal to x squared plus 3, 4x minus 1. In this example, we will use the FOIL method since this example is multiplication of two binomials. FOIL is a mnemonic which stands for first, outside, and inside, last. We multiply both the first terms and we get 8x cubed. The outside terms 2x squared and negative 1. We have negative 2x squared. The inside terms we have plus 12x, and the last terms since we are in multiplying. Two unlike signs we will get a negative sign. The product is negative 3. F first 8 times cube outside negative 2x squared inside plus 12x. L negative 3. Answer is 8x cubed minus 2x squared plus 12x minus 3. Quotient of two functions. Fourth topic is about division, or I shall say the quotient of two functions to give you a better insight. I leave you an example. First, we define two functions, f and g. F of x, 25x squared minus 9, and g of x, 15x squared plus 16x minus 15. F of x equal to 25x squared minus 9. G of x equals 15x squared plus 16x minus 15. The numerator will be the f function, and on the other hand, the denominator will be the g function. And recalling what we have learned during the junior year, we know that the numerator is a difference of the two squares. In this example, it can be factored into two binomials 5x plus 3 and 5x minus 3. The denominator, however, can be factored into two binomials. Also, using trial and error, we can get 5x plus 3 and 5x minus 3 as the two factors, since we have a common factor which is 5x minus 3. It can be cancelled out, and that leaves us our final answer, which is 5x plus 3 over 3x plus 5. F of x over g of x equal to f over g and x equal to 25x squared minus 9 over 15x squared plus 16x minus 15. 5x plus 3, 5x minus 3 over 5x minus 3, 3x plus 5. Final answer is f of x over g of x is 5x plus 3 over 3x plus 5.
Product of a constant and a function. The last subtopic would be the product of a constant and a function. In mathematics, a constant is a value that doesn't change. All numbers are constants. For instance, a certain letter can denote a constant number like x equals 9 and y equals 1.5 and so on. To give you an insight, I'll give you an example so you won't be lost. First, we define a function denoted by a letter. F of x equals 3x squared plus 9x negative 21. In this example, we will multiply 2/3 of function f. Thereafter, we distribute 2/3 to each term of the polynomials, and this gives us a product as our final answer. 3x squared plus 9x minus 21. So that concludes our lesson for today. To recapitulate, we have discussed the operations of functions, and this covers 5 subtopics: sum of two functions, difference of two functions, product of two functions, quotient of two functions, and product of a constant and the functions. I hope you students have learned so much today. See you next meeting and stay safe.